Hi, my name is John.
And my name is Alice. You're watching Math Videos for Parents. We help you so that you can help your kids with math. And today we're doing something really fun. We're doing some word problems. Now, John, I've always liked word problems, but I know like they're kind of popular memes on, you know, how they don't make any sense. But they actually do if you just kind of step back and are able to break them down. That being said, though, this is a different type of word problem than what I remember having growing up. When I was growing up, we were taught to look for certain keywords. This problem doesn't seem to have those. Also, the word problems I used to have usually had one answer, but here the answer is actually how many answers are there. So it's kind of a level higher. So I'm curious to hear how you would approach a problem like this.
Yeah, so first of all, I would say that if you see the word array, don't panic. I think that creates an unnecessary level of fear or anxiety with the problem, but there's nothing to worry about. Like we showed in a previous video, an array is just an arrangement of items. So we're looking to take 28 math shirts and lay them out in rows and columns so that they're neat. And if you're familiar with the word factor, maybe you remember the word factor from grade school and like numbers that go into other numbers. That's basically what this problem is about, except that, we're not using those words. We're having students sort them out in ways that are natural to them. So I think a lot of students most immediately recognize 28 as 7 times 4. Or at least, that's the first thing I think of. So one array that they can come up with is a 7, and these are I guess these are t-shirts wrapped up in a circular format. We can set this up in an array that is 7 by 4, and we'll just assume that each circle is a t-shirt.
I would love to have 28 math t-shirts.
Same here. So that would be a 7 by 4 array that would give us 28 t-shirts. We can also rearrange these shirts so that we go a little bit longer. We can do a 4 by 7 array and still have the same number of shirts, but just, arrange them in a different way. 2, 4, 6, 7. And as I'm drawing this, I teach college linear algebra, and I'm thinking of matrices and their transpose, how rows become columns. So it's really interesting to see that those seeds are like planted from a very young age in basic multiplication problems. And when they get older, if they take math in college, that they'll need to do things like this. And we can break it down even further. So knowing that 4 is an even number, we can divide 4 by 2 and come up with an array that is 2 by 14. That's a lot of circles to draw, but this time we will only have 2 columns: 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So we can draw it this way as well. But then if we, let's say we're laying these shirts out in our room and we don't have the space, we need to sort them out a different way. We can sort them out horizontally and do a 2 by 14 array if we wanted to, and just, have the 2 rows go this way. I'll save you the pain of trying out all 14, but just putting 14 out that way as well. Believe it or not, there's actually 2 more that we can do. 28 is also equal to 28 times 1. That's always, 1 is always a factor of any number. It's a default factor that we have. So we can always have an array that is composed of 1 column or 1 row. So we can also do 1 by 28 going this way. Or we can go 28 by 1 this way, which will still give us the same area of 28. So I have a total of 6. I don't know if we want to cut these shirts in half and do fractional parts. Half a math shirt's not really fun.
Good math shirt.
It is. So we'll stick to just whole numbers here. I would say there's a total of 6 arrays.
All right, wonderful. So I think, John, what I'm going to do is a good kind of mnemonic is when you think of array, think of arrangement.
Yes, exactly.
That's a much more approachable, like an arrangement word problem. Well, we all know how to arrange shirts. I mean, I may not do it, but I know how to
Right.
at home. All right, great. I'm looking forward to trying one.
All right, sounds good.
Okay, so now I'm going to do an array word problem. I'm going to think of arrangement. John, I noticed that you don't have quite as many math t-shirts as I do, apparently. You have 16 math t-shirts.
Gotta catch up.
Quite a few. How many different arrays can he make of his math t-shirts? So one thing I'm going to do is I'm just going to approach it by starting from the kind of the smallest number. That way I also won't forget it. And that is that 1 is a factor. So I'm going to say, okay, 1 row of 16 shirts. So one answer would be 1 by 16. Now I'm going to go up and say, okay, well, does 2 go into 16? And it does. So give myself some room here. I'm going to do 2 rows of 8 shirts. Oops. Okay, so that's 2 by 8. Sorry about that. Then I'm going to say, okay, does 3 go into 16? And it does not. 1 plus 6 is 7. 7 is not divisible. Does 4 go into 16? It does. So I could make 4 rows of 4 columns, 16. So that's another one. And now I'm going to keep going. 5 doesn't go into it. 6 doesn't go into it. 7 doesn't go into it. But 8 does. And now it's like, whoosh, 8 by 2, right? We already did 2 by 8, but it's commutative, as we saw. So we could do 8 by 2. I'm not going to draw it out because I feel like you all know how to draw 16 circles by now. And then I can keep going, but basically we would have already caught everything. So now we just have to make sure we're doing the commutative of it. So 16 by 1 is another one. So in this case, we're going to end up with 5 arrays. And at first I thought, well, wait, why am I ending up with an odd number if we can flip everything? But that's because 4 by 4, if you flip it, it's still 4 by 4. So it looks like we're going to have 5 possible arrays of t-shirts. John, what are your thoughts?
Absolutely love it. I just see middle school, high school, college level math oozing out of this. Like it's just such an important foundational concept for students to understand that they're able to make 16 using a variety of different sets of factors.
I love it. I love it. One day these kids will go into linear algebra and they'll remember doing a word problem about your math t-shirts. All right, wonderful. Well, if you have any problem requests, please don't hesitate to just shoot us an email, take a picture of a problem, send it to us. We're at mathvideosforparents@gmail.com, or leave us a comment on our YouTube channel or on our Facebook page. Thank you so much.
Have a great night.